Hello everyone, welcome to today's class. In this lecture we'll discuss about differentiation of implicit functions. So implicit functions are those kinds of functions which cannot be written directly in form of f of x, means we'll be generalizing the relation between x and y in form of an equation. Okay, let's see how this differentiation works. So before starting the question, let me give you one brief idea. So these are implicit functions. So the idea is, remember chain rule. If your variable, suppose d by dx of sine x, okay, that is your cos x, because we are differentiating sine x with respect to x. But if the question was differentiation of sine, let's say y or z, okay, let me relate it first z, then I'll introduce y. Okay, something was complicated, we considered that to be z, so d by dz of dx, so that will be again cos z, instead just that additional term of z dash or dz by dx comes with it. That is because chain rule. So same thing we'll do here also. If any function is of y, suppose sine y, and we have to differentiate with respect to x, okay, we'll be always differentiating with respect to x. So if we are differentiating with respect to x, so in that case it will be cos y into dy by dx. So whenever y will be differentiated, you will get additional dy by dx in that term. Okay, it is because of the chain rule itself. Let's look at the question now. Okay, first question, this is 2x plus 3y equals to sine x. So what we are going to do, we'll differentiate both sides with respect to x. Okay, we'll differentiate both sides with respect to x. All right, so differentiation of 2x is 2, differentiation of 3y, so y will be differentiated kind of like x. Differentiation of y will be like differentiation of x. Differentiation of x is 1, differentiation of y will also be 1, but additionally y dash will be there. Differentiation of x square is 2x, differentiation of y square will be 2y, additionally y dash in multiplication, chain rule. Okay, so 3y differentiation will be 3y dash is equal to sine x differentiation is cos x. So directly we get y dash is equal to cos x minus 2 upon 3. It's a simple question. Okay, to get you through the fundamental, these questions are very easy as such. Let's look at the next question. This time it is 2x plus 3y is equal to sine y also. Now I think for the first question you can think that we can generate y as a function of x and then differentiate, but here y is present in algebra also and y is present inside the trig, so you cannot generate y is equal to something. So for that, what do? We differentiate both sides directly. So differentiation of 2x, now I'm not writing, differentiating both sides with respect to x, it's understood. So 2x differentiation is 2, 3y differentiation is 3y dash, sine y differentiation is cos y into y dash. Okay, now we are supposed to find y dash, dy by dx, na, basically y dash is dy by dx. This is what we need to find. So get your y dash together. So 2 is equal to cos y into y dash minus 3y dash. So 2 is equal to, take y dash common, this is cos y minus 3. Okay, so 2 upon cos y minus 3, that's your y dash. Okay, simple enough so far. Next, ax plus by square is equal to cos y. Okay, ax plus by square is equal to cos y. So same idea. Differentiation of ax, a and b are constant, so differentiation of x is 1, b into differentiation of y square will be 2y into y dash. Cos y differentiation is minus sine y into y dash. we are supposed to find y dash. So get them together. So a is equal to minus sine y into y dash and minus b or 2by dot y dash. Take y dash common and negative also let's take common. So sine y plus 2by get everything in the denominator. So negative, if we take it on the other side, it will become minus a upon sine y plus 2by. That's your y dash. Okay. So the idea is very simple. You differentiate both sides. Whenever you differentiate any term that consists of y, additionally multiply y dash with it, and we are supposed to find y dash, so get your y dash together. Okay. All right. Let's look at the next question now. Now things will start to get slightly complicated, not too much. So I'll introduce one question at a time. Okay. All right. Next is this function. Again, you cannot generate y separately, and remember this is tan x separately and y separately. Okay. So let's differentiate both sides with respect to x, but the problem starts with this 2. Two things are being multiplied, that means uv. So that means we have to multiply it. Okay. Means we have to apply the uv rule. So uv rule is, I'll write it in steps for first time. Differentiation of x, y as it is. Differentiation of y, x as it is. 2y square differentiation is, y square differentiation is 2y into y dash. Tan x differentiation is sec square x. Y differentiation is 1 into y dash. Okay. Now the idea is to collect all y dash term. This is y dash term, this is y dash term. X dash is 1, so basically 1 into y plus this is also y dash. So 3 terms. Okay. So take these 3 terms together. So let it be here. Y plus x y dash plus 2y y dash. Take this term also here, minus y dash is equal to sec square x. Take this y on the other side and take y dash common from these 3. So x plus 2y minus 1 is equal to sec square x. So we get y dash as sec square x upon x plus 2y minus 1. That's your answer. Okay. Again, no matter how complicated the expression looks, the idea is to get all the your y dash together and solve it. All right. Let's look at the next question. All right. Fine. Let's differentiate. X square, xy, y square. X square normally, y square normally differentiation. Xy, then again we have to use uv. So x square differentiation is 2x, xy differentiation of x is 1 into y, differentiation of y is y dash, okay, into x. 2 y square differentiation is 2y y dash is equal to 100 is constant differentiation is 0. Collect your y dash, rest everything has to go on the other side. These 2 terms will take it to the other side. So y dash x plus 2y is equal to, take this on the other side, you will get minus 2x plus y. Okay. So y dash is equal to minus 2x plus y upon x plus 2y. Okay. So far nothing complicated. What we are doing is just differentiating, then taking y dash common, then getting y dash. Okay. The only thing that you have to remember, is whenever y gets differentiated, treat it like x, is just that additionally multiply y dash with it. Okay. All right, let's look at the next question. Let's take trigo also now. Okay, now this is interesting. Let's see why. Sine square y cos xy. Okay, sine square, you cannot directly differentiate, you have to use chain rule. Cos xy, again cos can be differentiated, but the problem is inside xy is there chain rule, so both time we have to use chain rule. Okay, so sine square y, I'll differentiate sine square y separately. Sine square y differentiation, let's write down. So I'll rewrite this as sine y whole square. Okay, and then we have to differentiate. So first bracket came, that is of square, so that is your first function. The bracket itself is a function of square, so get everything inside that as z. So z square differentiation. Okay, that's 2z into z dash, that's 2 sine y into z is, what was our z? Sine y differentiation, na? Sine y differentiation. So 2 sine y differentiation will be cos y into y dash. Okay, and if we want, we can combine this. I'll combine it using the trigo later if required. Okay, same thing we'll do with cos xy differentiation. Now this time it's only cos, so cos is okay, it's just that whatever present inside, whatever complicated thing, consider that to be your z. Okay, so it is looking like cos z differentiation, which is minus sine z into z dash, so minus sine z is xy, and then differentiation of y dash means xy differentiation. And for this you will have to use uv. Okay, so minus sine xy, let's apply uv. So differentiation of x1 y as it is, differentiation of y dash into x as it is, so 1 into y dash into x. Now I have differentiated both the expressions. Let's now do the differentiation of whole expression. So that means differentiation of this, differentiation of this, differentiation of pi. What is the differentiation of pi? 0. So sine square y differentiation is 2 sine y cos y into y dash, plus cos z differentiation is minus sine xy, 1 into y is y plus y dash x, and right side pi differentiation is 0. Let's see, 2 sine y cos y y dash, let's multiply this first of all with this, so you'll get minus y sine xy and minus x sine, not x sine, no, x y dash, x y dash or y dash x sine xy equals to 0. Now this term contains y dash, this term contains y dash, this term doesn't contain y dash, take it to the other side, 2 sine y cos y minus, if we take y dash common here, minus x sine xy completely multiplied by y dash is equal to, if we take this to the other side, y sine xy. I think last step is very simple now. So y dash is equal to y sine xy upon 2 sine y minus x sine xy. Okay, so yes, I have taken more steps, but what you can do is you can directly differentiate accordingly in one single go. You don't have to separately differentiate. If you are comfortable with chain rule, you shouldn't be having trouble with writing this expression. Okay, y sine xy sine, sorry, this is two sine y cos y. Okay. And I was expecting something to happen, but it didn't happen there. So 2 sine xy, you can rewrite this as y sine xy upon 2 sine theta cos theta is sine 2 theta. So sine 2y minus x sine xy. Okay. All right, we're done with this. Let's look at the next one. Okay, so pretty much the same idea with the next one also. Sine square x plus cos square y equal to 1. Okay, so we have to differentiate this. So let's differentiate. Sine square differentiation, this time I'm going to write directly. So considering it to be z, so it will be 2 sine x cos x. Cos square differentiation will be minus 2 cos y. Cos y differentiation is minus sine y, that's why I put minus sine y into y dash is equal to 1 differentiation is 0. So I think it's very obvious now. Y dash is equal to, sorry, don't take y dash, let's write down one step. 2 sine x cos x can be written as sine 2 theta. This one also can be written as sine 2 theta. So sine 2x minus sine 2y into y dash is 0. So y dash is sine 2x upon sine 2y. Okay. That's your answer. So implicit function differentiation is very simple. Sometimes it's slightly lengthy, very slightly, but the chain rule application is again here. Now let me give you one more question. All right. If we look at this question, first thing that we can see is we'll have to apply UV here, we have to apply UV here. Okay. And then we'll collect y dash. Okay. It will be lengthy, slightly lengthy. Now I'll teach you the short way to do the differentiation of implicit functions. But remember, that is only for objective, because that kind of technique is not applicable normally. So because it involves partial derivatives as such. Partial derivative is not in your syllabus, but I'll teach you what is this. So dy by dx directly you can calculate by differentiating partially the function, whatever function of xy is given with respect to x, upon partially differentiating function with respect to y. Okay. Now let me explain what is partial derivative. So partial derivative, first of all, what's your function? If you rewrite this as x cube plus x square y plus xy square minus 81 equal to 0, then it's called your function of x comma y. Okay, so that function we have to differentiate with respect to x. So you don't have to follow the notation, you just understand that you have to differentiate this function with respect to x. Let's, for simplicity, let's not write xy, let's just call it as a function only. Okay, because this is not in your syllabus anyway, so why bother with notations? So partially differentiating with respect to x, assume y to be constant. Okay, means you have to treat y as a constant. So differentiation of y square will be 0, differentiation of y will be also 0. Okay, assume y constant. So let's differentiate. First of all, this x cube differentiation is 3x square. Y is constant, forget that, means leave that. X square differentiation is 2x. Again, y square is constant, so leave it because in multiplication with x, so differentiation of x is 1. And y cube was also there. Plus y cube is equal to 81, no? Sorry, minus 81 equals to 0. This is your function now. Plus y cube is constant. See, y is constant, so the cube of it all will also be a constant. So differentiation of y cube will be 0. That's the meaning of partial derivative, okay, is equal to 0. Constant differentiation is again 0. All right. Again, partially differentiate with respect to y. Okay, this time assume x to be constant. Okay. Now, if you have to consider x to be constant, that means differentiation of x cube, only x cube, will also be 0 because it's a constant. X square y. So you have to now differentiate with respect to y. So focus on y. X square is in multiplication, leave it. Y differentiation is 1. Okay, and don't apply y dash with it. It's partial derivative. Just differentiate with respect to y. Differentiation of y square, x y square, no? So x is as it is, y square differentiation is 2y. Y cube differentiation is 3y square, and 81 differentiation is 0. Okay. All right. Now what we have to do? We have to divide them. So I can directly say dy by dx is equal to negative of 3x square plus 2xy plus y upon this is x square plus 2xy plus 3y square. Okay, so if you look at the number of steps are very less for this question. Let me first check the answer. We have got minus 3x square, and this is correct answer. Okay, so this method is like a effective shortcut how to do this differentiation of implicit functions literally in one step. Okay, you will not be writing these two steps separately. I have shown that to make you understand how you have to differentiate. So main thing is you get all your function on the left, right side should be 0. That will be your function. When you are differentiating with respect to x, assume your y to be constant. So if y is constant, y square will be constant, y cube will also be constant. Similarly, if you are differentiating with respect to y, assume x to be constant. Okay, and this works on every single question that we have done actually here. Okay, you can check like for this question. Let me show you for this in one step. Dy by dx is equal to differentiate this with respect to x, negative of differentiate with respect to x. So y is constant, so this is minus tan x minus tan y then, okay, is equal to 0. We have to generate, so we have to differentiate with respect to x. So first differentiation becomes y plus y square is constant, leave it. Tan x differentiation is sec square x. Okay, what's wrong here? Okay, the answer that we wrote here is wrong. What's what I'm saying? This one I forgot to take it on the other side. So this was minus y. So this will be minus y. So negative of, now it's coming, minus sec square x. Y differentiation again 0. Done. Now differentiate with respect to y. So y differentiation becomes 1. So x. Y differentiation becomes 2y. Tan x, x is constant, so tan x is also constant, 0 differentiation. Minus y differentiation is minus 1. See how easy this is to do this in one step. Okay. I'll show you one more example. This one was there, no? dy by dx directly in one step. Negative of, differentiate with respect to, get this on the other side, differentiate with respect to x. So minus 2x, differentiation of x is 1 into y. Y square differentiation will be 0 because we have to assume constant, upon, here bracket is also missing, okay, upon, now do you have to differentiate with respect to y. So x square differentiation will be 0, y differentiation will be 1, so x into 1 plus y square differentiation is 2y. Okay, so that whatever I taught was fundamental, and this is shortcut. Okay, but you should be comfortable with while understanding partial derivative, how we have to treat x as constant, how we have to treat y as constant. If you are comfortable, use this, otherwise go for the basic. Okay, all right, we have done this now. I think that's it. That was your differentiation of implicit functions. Okay, now there is some inverse functions are also involved, but we'll deal them separately in inverse. Okay, so differentiation of inverse functions will be dealt in the chapter of inverse functions. Okay, fine, I'll end the session here. We'll continue with the next topic, that's your logarithmic differentiation in next class. Okay, and that's it for today. See you in the next class. Good day.